Greetings, fellow viewers. So today we're going to be talking about the mole. No, not this one, and definitely not this one. We're going to be talking about the chemistry mole. So basically, what is a mole? A mole is basically just a unit we use to describe the number of particles of an element or molecule, something. Yeah. So basically, something like a dozen. So let's say I have a dozen apples. So from this we know that we have 12 apples. So it's same for the mole. When I have 1 mole, I will have 6 times 10 to the power of 23 particles. And these particles, they can be atoms, molecules, even ions. So this number over here, this is Avogadro's constant, or number, yeah, what you want to call Avogadro's constant. So basically, when I have 1 mole, it means I have 6 times 10 to the power of 23 particles. So let's do an example now. Let me whip my periodic table out. Alright, so let's say I have 1 mole of hydrogen atoms. That would mean that I have 6 times 10 to the power of 23 hydrogen atoms. Alright, let's say I have 1 mole of sodium atoms. That would mean I have 6 times 10 to the power of 23 sodium atoms. Alright, let's say I have 1 mole of oxygen gas. That will mean I have 6 times 10 to the power of 23 oxygen molecules. Alright? So that's what a mole is. So how do we get the mole? So there's many ways we can derive to a mole. Firstly, I'm just going to tell you how to get a mole if you have the number of particles. So let's just say I have... okay. Let's just say I know that I have 6 times 10 to the power of 23 potassium particles. Potassium atoms, sorry. So to get the number of moles, you just have to take the number of particles known divided by Avogadro's constant, which is also 6 times 10 to the power of 23. So since I have 6 times 10 to the power of 23 potassium atoms and I want to find how many moles of potassium atoms I have, I just take 6 times 10 to the power of 23 divided by 6 times 10 to the power of 23, which will give me 1 mole. So I have 1 mole of potassium atoms. Alright? So next question. Let's say I have 12 times 10 to the power of 23 oxygen molecules. Yeah, oxygen molecules. So I want to find how many moles of oxygen molecules I have. So I'll just take 12 times 10 to the power of 23 divided by Avogadro's constant, which is 6 times 10 to the power of 23, which will give me 2 moles of O2 molecules. Alright, let's do one more. So let's say now I have... let's say... still thinking. Oh, yeah, okay. Let's say I have 0.6 times 10 to the power of 23. What should I use? Let's use arsenic. Say I have 0.6 times 10 to the power of 23 arsenic atoms. So I need to find how many moles of arsenic atoms I have. So 0.6 times 10 to the power of 23 divided by 6 times 10 to the power of 23, which will give me 0.1 mole of arsenic atoms. So yes, this is how you find the number of moles if you have the number of particles. So now we move on. There are other ways, like I said just now, to find the mole. So that what if you don't have the number of particles? Then how are you supposed to find the mole? Well, fret not. There's another way, which is you can take the mass of a known substance, then you divide it by its MR or AR, depending whether it's a molecule or atom, and you get the number of moles. So let's try this out, yeah? Let's say I have 32 grams of oxygen gas. I want to find out what is the number of moles. So basically the MR of O2 is just 32. So 32 grams divided by 32 is just 1 mole. I have 1 mole of O2 molecules. Alright, let's do nitrogen gas. Okay, so I have 14 grams of nitrogen gas and the MR of nitrogen gas is 28. So 14 grams divided by 28 will give me, you can try and guess. Okay, you can get half a mole, or you can write it as 0.5 mole. Yeah? Alright, so let's do one more. Let's say, let's do, alright, let's do calcium. Let's say I have 80 grams of calcium. So the AR of calcium is 40. So 80 grams divided by 40 will give me 2 moles. So now you know, yeah? So you can use the mass of the known substance divided by the MR or the AR to find the number of moles. Alright, so what if you're asking, okay, so what if I have the number of moles of the substance, but I don't have the mass? So how am I supposed to find the mass? Very easy. So we know the mass over the MR equals to the mole. So now let's say I have 4 moles of chlorine gas. Okay, so yeah, we have 4 moles of that. So the MR of chlorine gas is 71. So as we know, our mass over our MR equals to our mole. But technically, if you use a bit of math here, you can cross multiply. So your mass will equal to your MR times your mole. So since we have 4 moles and we know our MR of chlorine gas is 71, so 71 times 4 equals to 284 grams. We have 284 grams of chlorine gas. Yay. Okay, so now we've got that done. Let's move on. So there is another method you can use to find the number of moles you have, and that will be using the volume of the gas. So in room temperature and pressure, 1 mole of a gas, the volume it will take up is 24 dm³. Alright? So by that conclusion, we can state that the volume of the gas known divided by 24 dm³ will equal to the number of moles. So let's try this out, yeah? Let's use oxygen again. So let's just say I have 104, oh my god, I have 144 dm³ of oxygen gas. Alright, so yeah, I want to find the number of moles. Very easy. I just take 144 divided by 24 and I'll get 6 moles. 6 moles of O2. Alright? So what if now I have... Okay, what if now I have 12 dm cube of hydrogen gas? Yeah? So basically just do the same thing and you get half a mole. So yeah, that's how you find the number of moles using different types. So let's try a practice question, yeah? Let's do this. Alright. Let's just do it over here. Okay. So, a mass of 7.2 grams of an oxide of copper was reduced to obtain 6.4 grams of copper. Calculate the number of moles of copper in 6.4 grams of copper. So remember just now, we have the mass of copper, and which way will allow us to find the number of moles using mass? Okay, that's right. We use the mass over MR, we'll get the number of moles. So the AR of copper is 64. So 6.4 grams divided by 64 will give you 0.1 moles. So therefore, you have 0.1 moles here. Now we need to calculate in 7.2 grams of the copper oxide the mass of oxygen atoms. Since we have the mass of the copper now, we can just take the mass of the copper oxide minus by the mass of the copper. And by doing so, we'll get 0.8 grams. So that's the mass of the oxygen atoms. So now they want the number of moles of oxygen atoms. Okay, so the AR of oxygen equals to 16. So 0.8 divided by 16 will give us 0.05 moles. So we'll get 0.05 moles. So using your answer to part A and part B, you have to deduce the formula of this oxide of copper. So basically we can just use a ratio to help us out. So our copper to oxygen, we can compare their moles. So for copper, it is 0.1 mole. For oxygen, it is 0.05. So we divide both sides by the smallest number, which is 0.05. So we'll get 2 to 1. So our formula will be Cu2O. And there you go. Right? So that does it for this video. Thanks for watching.